If you don't recognize me, my name is Kedar. I'm helping NRF with the AI Science Initiative. I just wanted to give a brief overview of where we're going with this. Really appreciate the organizing committee here doing this on such a this. Thank you very much, Chee and Ben, putting together what looks like an amazing workshop. I understand time was short, but essentially it's a ground up community building effort. So it's just the beginning of journey. So we're really happy that you're here. So I'm actually a faculty in material science. I know very little about education apart from teaching students. But the idea here is that if you go to the website, there's an AI for Science initiative that NRF is leading. And the idea behind this is essentially, I think, is basically to see, the question that we're trying to ask came inspired from a workshop that we attended back in February. So this is called the Nobel Turing Challenge. The focus here is, if you're aware of the Turing test, can you do a Turing test at Nobel quality scientific activities? Or in your case, perhaps you can think of science of learning activities, right? So can the Nobel Committee give an AI system a Nobel Prize without noticing it's an AI system? So, Professor Kitano, who was the founder of the RoboCup, some of you might know about this, has come up with this. There's been a series of workshops. So in July, we're going to have the AI for Science conference, which is in tandem, it will be held parallel with Kitano's NPCI workshops. That's what we're working towards at the end of the summer. So if you haven't seen the scoping report, I think we wrote an NRF scoping report. You can find this on NRF's website. And essentially, we want to define AI for Science and differentiate it from the science of AI or AI for X, right? So the AI for Science is essentially the general effort to use AI to solve problems for scientific discovery, right? So it's more fundamental in nature. And we want to look for transformative sort of achievements that are only enabled through AI and technology. That's the idea. Science of AI is essentially where we do AI development anyway, different architectures, GADs, and so on and so forth, right? AI for X is the implementation. So perhaps in education, you have a lot of this. And, I'm sure there are other avenues for funding there, but that's not what we're looking for here. We're looking for things which are, can you do AI to improve the foundational understanding and improvement of education, right? So the way the program initiative is being run, there's a top down and bottom up. There's areas of interest for Singapore, areas of strength for Singapore that will definitely be supported. Okay, so there's no favorites at this point, but there are about 16 of these workshops that have been held or are being held in this month. So this is workshop month, right? And then there are also bottom up. So there's, for example, physics and complexity science came from the community, and they had a workshop similarly. And the idea is to articulate this vision of what AI for Science means in your community. What's important, of course, underneath, and you can make an ask for this, is data and computational resources. What kind of resources do you need, including talent, for instance, that is necessary for you to succeed and show that Singapore is ahead of everyone else? Okay, so this is actually the timeline. So we are here, the thematic workshops. We're into May, as things run late, they are, right? There's been study trips that have been organized. I accompanied NRF and PS to the US. There's been trips to Europe as well, and there'll be one to the UK later in the summer. And myself and Professor Sang Yang in the Computer Science Department in NUS are drafting the Foundation Research Capability Study Report, which we'll get input from all of you, especially your thematic leads here, and they will engage with you further if there's clarifications required. And we're doing the workshops, so please mark those dates. It'll be the 23rd and the 24th of July this month. And eventually all of these will go into the grand challenge and call proposals, which NRF will handle later this year. So there are two parts to this. This is an illustration of the workshops. Please do check out the website. It'll keep getting updated. Your workshop is on there. We'll collect all the information here. And there's various themes that have already been held. And these are all the ones that are coming up. Some dates are still to be finalized. For example, there's new ones on digital phenotyping and sustainability coming up in May as well. And basically, the purpose from today's workshop, what we are seeking from you is essentially this. What is the vision statement? Right? What are problem statements and targets for potential AI science areas in your field? Right? Please articulate the challenges and the bottlenecks. How does Singapore stand here? Where do you get the data from? Is it complex for your AI-based solution? Right? And what we're really looking for is transformative ideas. Thinking about the proposal in the future, please explain how this idea or challenge is transformative. The data sets and the HPC resources that you require. Right? So that's what we're looking for. So The tangible outcome from this workshop is a white paper. So I will work with Ben and Seng on collecting this. All of your inputs will go into that white paper that will be part of the FRC report, right? And eventually, with networking with people in this community, hopefully you can come up with concept papers that you can then submit for your grand challenge that you have. So it's two parts, right? Your inputs today will be part of the national report. And just to talk about the FRC, if you're not familiar with this is going to all stakeholders, government, regulatory boards, faculty, of course, international viewership. So everyone's going to see that piece. So it's your chance here to make a case for what it means to do AI for science and education. So with that, I won't take any more of your time and hand it over to the main case. Thank you. So any questions? All right, thank you.
Thanks, Kedar. Ben and I will be co-facilitating this workshop. So basically, that's the agenda for today. We're now at point number 2 here, introduction. After this, we'll have short presentations of about 1 hour from various researchers from NTU, NIE, NUS, ASPA, as well as MOE. And we'll break down in small groups for discussion. That's where we will solicit your wisdom and your ideas. Okay, that's actually the most important part we hope to get from you today. And we'll have a lunch, and then we'll come back for the group presentations and vice versa. Okay, so this is roughly the schedule for today. Let me give you a little bit background from education perspective. We all know that Singapore is very famous for education. We do very well for PISA, for teams, etc. Okay, but knowing that today's world is so different from yesterday's world, some people say VUCA is already outdated. We now go for Benny. I'm not sure whether you have Benny. Brittle, anxious, non-linear, incomprehensible world. So is it good enough for students to do well in tests? Perhaps not. So what do we look for now for new education goals? Mr. Education just mentioned about a few things: creator, contributor, connector. So these are things that we need to be able to help our students to develop into. So Ben and I brainstorm certain ideas of themes for today's sessions. Things like AI for knowledge creator. We want to develop our students to have more agencies in their learning, to shape their futures. In fact, they will shape our futures as well, right? So we need to be able to have the new generations of learners who have agency, who can direct their own learning and be self-directed and lifelong learners. And very importantly, well-being. I think increasingly we know that's an issue: psychological well-being, physical well-being. Now, in order to achieve all these goals, we also need new methods of teaching learning, new methods of assessment, as well as new methods of studying teaching and learning. And therefore, for today's workshop, we'll start with some presentations first. We'll see some ideas. Okay, and some of these ideas are work in progress, not perfect yet, but basically to trigger a discussion. We actually hope to get more from you. Like what Kedar said, we received this assignment quite late, so Ben and I were thinking that nobody will turn out. Okay, but we're very surprised that all of you turned out this morning. Very good sign. And so I'll pass time to Ben, and then we'll do the short presentation.
Right. Thanks, Chee. And first, on behalf of Seng and myself and the NRF Knowledge Committee, I'd like to thank all of you for taking time today to turn up for this workshop. This not a very good time actually. Exams are like finishing. A lot of people are leaving the lab for vacations. So first, before we start, I want to thank actually Hans. He's been quite last minute thing, and he's been quite fabulous in terms of getting everything together. Very helpful, right? A lot of people like Hans, I think this thing will happen. And also today we're going to have several facilitators and speakers who also agreed to do this on a very last minute. So again, we are truly grateful for your help. One of them actually got really sick and couldn't turn up. Later I'll be doing something on his behalf now. So first of all, I think to add to what Kedar has said very well, and Seng has said. So at NUS, I'm actually the token AI for education guy at NUS. It doesn't really have an education school, right? So, but what's happening at NUS is that we started this NUS AI Institute recently, right? And the general observation is AI is big, right? So we want to have the computer scientists, people like me and my colleagues in the sport instituting to see how we can help the other parts of NUS adopt AI in their work and do better, right? So in this way, we are doing the same thing at this workshop here. Now, actually, AI education is a bit difficult, right? Why? Because oftentimes most of education, I think me and Seng we have discussed that. Education is fundamentally a very human problem, right? It is, and one of the things that's interestingly, as a computer scientist and software engineer, I teach my students is this, right? Software and computer science cannot solve human problems at some level. So actually, one of the things that I think we discussed and we like to kind of like see if we can avoid is instead of being, looking at the problem from an AI first kind of perspective, as in having a tool, being a solution, looking for a problem. I think the focus today, Siew has agreed, is that we want to have this workshop focus on the education domain side house. Okay, now the people here are actually quite diverse, and that's actually on purpose. I mean, you can imagine in this room there are actually the education people, mostly from Seng NIE side of the house. Okay, NUS side, I think many of my guests here are from the computer science, the technology side, and we also have Nancy and A-star people, right? So part of this whole entire workshop also has this element of matchmaking, right? So I think it's important for people on both sides of the house, the education side as well as the CS side to come together and discuss what the fun problems are. But I think Siew has agreed that today's focus, hopefully we can try to focus and the facilitator signal that we will try to define really the education problems from the education domain side, okay, and see how we can do better with AI. All right, with that, I think we should start. All right, thank you very much. Okay, hope you enjoyed this session. Thank you.
So this order of presentation, so the NIE and TU can go first. Okay, that is our presentation titles, and then NUS, A-star, and MOE. MOE presenting using SLS learning space to support educational research. So I think I'll now pass the time to NIE and TU team, starting with Alwyn.
Morning and thank you everyone. My name is Alwyn and I was in Seng I won my first, but anyway, someone has to go first. So my name is Alwyn again. I'm from NIE. We actually look at a lot of teaching and learning in NIE itself. There are different offices there and sorry. Okay, and I was just saying that we look at a lot of teaching and learning, and we also look at things from a very wide perspective. Such as looking at how students become better learners, how teachers can become better teachers, and also in a very general sense, how they can actually become what we call knowledge creators. How they become knowledge creators. So I think it's a very new term to a lot of people who maybe are not too skilled in the pedagogical side and teaching aspect of education. So today, I will not be mentioning everything. I'll just be touching on the first point. After that, I'll pass it to Siong and also to Answer to talk about the other two aspects. So I understand we only have a very short time for this, so I'm just going to run through some of these things here. So essentially, from NIE perspective, and also from where I come from, the Office of Education Research, we actually are looking at how students can actually thrive in a knowledge society. So we are looking at things as in where students are growing up into what we call workers within a Singapore global society. And then in a very general sense, we are looking at knowledge as currency nowadays, whereby students use it to be able to work with things in global emerging societies, whether it's in New York, Tokyo, London, Singapore. This thing is actually ongoing and also very emergent. So we do recognize that we need to go beyond what we call acquisition mode. That's whereby you try to adopt and bring in all this kind of information and ideas and knowledge into the classrooms. But in a way, are they actually able to apply and use this thing beyond the classrooms itself? And therefore, I think that's something that we have in problem one, which is a lot of us may be familiar with how we can use AI, but that's from our perspectives. Can we actually bring it into the classrooms? Can we actually allow this to be extended beyond the classrooms? And also in some ways be able to support the knowledge creation process. The process itself is essential to everything that we're doing nowadays. As you can imagine, you're writing papers, publishing articles, you're trying to even maybe write this white paper that we're trying to do here also, and all the different type of stuff in the world that we're looking at. So problem one is a problem that we do envision not to be able to be solved in the very short term, but something that's going to be for the long run. Problem two itself is actually looking at it from a pedagogical perspective, whereby we try to integrate the AI tools into what we call pedagogy and practices. Because in some ways, when we actually teach, whether it's in NTU, NUS, SMU, all these universities, but also when we think about it, where the teachers, the K-12 teachers, when they are teaching in the classroom itself, they may not have the support from the universities or what with their everything. And therefore, we need to be able to integrate these tools into the curriculum, in pedagogical practices, in a seamless manner. Not to the point whereby you throw them the tools and then you expect them to be able to use it endlessly on towards the end of the year, and then after they come back and say, oh, the tool has broken down, I decided not to use it. So most AI tools are providing a lot of scalability, things like ChatGPT, Llama, Palm, all this, they only need a Google account. And teachers have that too. They are able to use it, but they do not know how to use it on a very sustainable basis. And that's what we are trying to build on. And so these are the two challenges that come together with two problems. And the first of which is we try to understand and also try to enhance the adoption of these tools and solutions to foster critical thinking, problem solving, and knowledge creation skills in students themselves. And then we try to work it out in a knowledge society like Seng. The second challenge will be to encourage and also how do we actually help the teachers to be able to adopt this AI due to the perceived implementation details and difficulties. Because if you speak to teachers and also speak to the different kind of stakeholders, including parents, so if you have children as a parent and the school asks you to use AI within this situation, how are you going to do it? And so we try to remove the barriers that's actually hindering the potential to enhance knowledge creation within the classroom itself. And so we talk a little bit about community efforts that we actually have so far with NIE and also in past with collaborators from all over the world. Essentially what we're trying to do here is to visualize learning itself. So we can do two things here. One is we can identify students' knowledge gaps. I think this has been something that has been ongoing for very long, but we are looking at it in a point whereby it is going to be very literal, very obvious to the stakeholders. Not just identifying it for articles, for our writing of papers and stuff, but more also bringing it into the classrooms to allow students to recognize what they know and do not know, and how to be. The second thing actually we're looking at is to highlight the ideas from the discourse. So communication is key for any classroom, and in some ways, it is important that we are able to sieve out, to extract, and to distill the essence of what students are talking about during the discourse. If you are able to do that, then we are actually able to sort of piece together what everyone is doing within the classrooms, beyond the classrooms, and also potentially bring it back as a blended learning environment, whereby people will not complain that what I learn in the classroom is different from what I learn at home. And so this is actually something that we're trying to do. The bottom left diagram actually shows a little bit of how students do feedback, and then they compare it to machine nowadays. I think the machine that we're looking at now is actually most likely in the form of a teaching aid, like generative AI. And then from the right, we actually have a visualization of how students' ideas actually can be visualized on the graph, like showing that whether some students' ideas are promising or not, whether some ideas belong to the teachers. So we do compare whether teachers' ideas are better than students or not. So it's a very qualitative kind of look at. So the second more recent development we have is actually regarding the community effort of using knowledge building. So it's an approach that's actually principle-based. And also we are looking at it as a suite of principles and practices that teachers can bring to the classroom in Singapore. It's been ongoing for actually 2 decades. So it's something that we have already been working on very long. What is more emergent and new is that we are actually allowing this KBLCT, learning companion for teachers. So we are helping teachers to design and also use the KB approach to be able to work with the teachers to teach them how to do knowledge building within the classroom itself. So you can imagine this KBLCT, which is actually right-hand side, is actually generative AI-based LLM. I would say a chatbot, layman-wise. So this learning companion-based LLM helps to support teachers in learning, and I think what Prof Ben Leong was talking about just now, which is we are looking at educational problem here and trying to solve it with technologies and not the other way around, whereby we try to feed the problem to the solution that we have. So in some ways, we try to also get teachers to reflect on their lesson design, something that they have already done, and also improve lesson design there. So of course, all of these things need to be supported by what we call data twin. So we are looking at these things with data that we have on hand, including what we call repositories of all this student discourse data that we have at NIE. So we have been collecting all of this data. I think there used to be a very big problem about 10 to 20 years ago, whereby collection of data was an issue. Nowadays, we don't have this issue. We have a new issue whereby how to analyze this data. And now we have moved on to the second phase, which is how do we then analyze this data in a very meaningful manner. I think that's the critical part of things, and that's why we actually focus on how we can actually solve these things through a knowledge creation process. So just some of the statistics here. We do have a lot of students' data. 20,000 notes might not be a lot to a lot of people in the AI sphere, but if you imagine in your whole life, you actually write more than 100 foreign notes in your life. I don't think so. So 20,000 is still quite a sizable amount. And of course, we can actually use a lot of LMS data because we have connection to schools, or educational stakeholders. So they'll be ready to share some of this data. And also, we have just attended a recent workshop SLS, the group itself, and then they also mentioned that you go to the next lab and sort of collaboration language. Yeah, and that's all. We're going to pass to the next speaker.
Siong. Oh, you're not on job.
No, yes.
Oh, okay.
Yeah, hello. My name is Siong and I'm from NTU. But I guess my background is a little bit different from most of the people here, at least from NTU. I'm from physics. Actually, I work in complex systems. And maybe because of that, I see things a little differently. But let me first get started on the talk that presentation that Chee wants me to talk about. So I guess I can start by saying that this year, I just finished teaching a course. This year, the lecture attendance is abysmal. I think, if I continue with the lecture tutorial format, right, in 2 cohorts time, right, I'll be lecturing to an empty lecture theatre. Because students don't want to come for lectures anymore. Okay, but even though they say they don't come for lectures, they like to watch recordings of the content. So therefore, the lecturing as a craft remains critical to their learning. It's just that they don't like to interact with a living person, they like to interact with videos. So many of my students, they told me that they watch YouTube videos and also lecture recording as the first phase of their learning process. But it's only the first phase. There's still a lot more things to do. And of course, one of the things that they pick is that, if you go to YouTube, you search for any topic, you get, thousands or 10,000s of hits. And which one do you watch? I think that they probably don't pick the one that is the most technically correct. They pick the one that is most engaging. Okay, so I'm not an expert on engagement and correlation with learning outcome, but these are some of the things that I managed to find. So let me now talk about challenges from my perspective as someone who's trying to impart knowledge on the students. This education is obviously a complex process in a complex system, so we expect things like critical transitions as well as history dependence. So let me explain a little bit what I mean by critical transitions. That means, you show students 3 examples, they don't understand. You show them 5 examples, they don't understand. You show them the 6th example, suddenly they understand. Okay, this has something to do with the way our brain is wired up. So they just need to see certain number and then they will go through. And this number is probably different from person to person. And history dependence means that if I have learned differentiation before, then this concept, which is not differentiation, becomes easy to me. Whereas if I have not learned it before, then even though you as an instructor, you say that this should not depend on differentiation, but somehow the students cannot get it. Okay, so and of course, if we so the big challenge statement, of course, is that teaching is very difficult. And as a starting point, we want to engage the students. So we want to have their attention because if they are looking at their handphone, then I think we don't need to continue lecturing. But unfortunately, engagement is not a point event, but a sequence of interaction between the lecturer, the student, and the content. So it's not just between the lecturer and the student, because we're not just telling jokes to the students, we refer to the content. And as such, right, there is an ecology of engagement sequences. In the education field, I think they have started to call this an epistemic network. I don't know how many of you have heard of this, but it's something new, I think in the last 10, 20 years. And it's still very primitive by my personal point of view. And obviously, there is maybe something that we can say is an optimal lecture for a cohort. So it may also not work for all the students. So let me continue with the community effort. So this is something that we have done together with a EU-funded Renoir project. They come to me and then they say they want to collaborate, and I am at a loss initially what to do with them. Then I offer up. I don't have the authority to offer up. I promise that I'll talk to people to get them access to the corpus of NTU recorded lectures. So if you count since 2003 during the SARS and pandemic, the NTU started recording lectures. If you start counting, maybe say 100 lectures per semester, then 13 weeks over the semester, or 13, yeah, and then 2 hours per lecture. We have actually a repository easily exceeding 50,000 hours of recorded lecture. So possibly most of those are bad lectures, but there are some good ones in there. So we can still try to learn from this data set. So the team from Poland is shown here, and this is kind of what we do. We coded a training set of about 200-300 hours of lectures. And then we organize them into pedagogical variables, and yeah. So this is the result of what I have found personally as doing network analysis. But the Polish team is actually developing a deep learning model to be able to automatically annotate the rest of the NTU corpus of recorded lecture, because 200 hours of annotation already took out the whole semester. Because we need to get 3 students to do it, and then after that we need to cross-check. We cannot possibly do 50,000 hours, so therefore this is what AI is useful for. And then of course, if we learn how different lecture modes can be engaging, then maybe we can design a dashboard for the lecturer, and that will tell the lecturer at a point when during the lecture live, that okay, you're getting too boring. Okay, of course not showing this to the students. Okay, then for data, of course, we still have not yet exhausted the capability of the NTU recorded lecture corpus. But you can imagine that for recorded lecture, we are not the biggest. So Coursera probably has a much larger, yes, it's a much larger. And let's not forget YouTube, which is actually students' favorite. So to go there. And of course, if you go to YouTube, some of the content that you find are not actually lectures. We can think of them as skits, but they are educational skits that people put up. Some of these can be in terms of some kind of challenge between 2 teams, and they want to solve a problem. And these actually are very engaging. So maybe we should actually learn from the team of SGCAG and how to develop educational material. Okay, so that's all I have to share for today. So the financial is going to take as well.
Hi everyone, my name is Siong, and I come from a different field. I won't say I came from a different field, but my position at the university. So I just want to share that I graduated from computer science in NUS. My PhD is with NIE, and currently am the head of the Learning Analytics Center at NTU. Okay, so the center name is Atlas. We are very new. We only come to existence in early 2023. So our positioning is to provide data and AI services for teaching and learning at NTU. And being a university level unit, you can imagine that the kind of questions we're asking will be how do we leverage AI and data to improve teaching and learning. So these are some of the problem statements that we are thinking about. So how should we identify students in need and provide early interventions for academic success? How can we support students to develop critical skills to remain employable? How do we update our curriculum and co-curriculum in a fast-changing world? Which I think Chee mentioned something about Barry. Benny. Okay, sorry. My hearing is not very good these days. So and finally, how should students be learning with generative AI? I think that these questions are really pertinent in the age of AI, especially for education. So as we investigate these questions, I think one of the challenges goes beyond just issues with resistance to education transformation. I'm trying to find people to actually participate in these investigations with my center. It is also about institutional challenges, which includes things like data ethics, data governance, AI governance. And I would like to highlight that this is not just about IRB, because the IRB may actually approve your research, but we may not be able to get the data due to some of the institutional requirements in relation to AI and data. And importantly is that sometimes we go for grants such as NRF grants, right? My sensing is that while we are posing some theories about learning in the age of AI, for example, but then if we're looking at transformative use of AI for education, then likely we need to be involved in some translational research. And hence, you can imagine that if you're going to build a model, you're going to build a tool, you're going to build an application, then the questions will be that how sustainable is that particular application? How can we scale it? Is it going to die once the grant actually ends? And I think that's the reason why a center like Atlas actually exists at NTU. So we are not a research center, although we have researchers. We actually exist as the nexus between research and application. So together with the entire university, so various units across the universities, what we I think in some parts we've already built it, but we are continuously building it, is an end-to-end data and AI platform. So the idea is that for any researchers or any developers, right, what we can do is that this has become a single platform in which that you conduct your research, you develop applications, deploy them, and we maintain them. Okay. So this is a very complex slide. I'm not going to go into detail, but I'm going to give you 3 examples, which is related to the projects that Atlas is actually involved in. And for those who are astute, you realize that the 3 listed projects here corresponds to the questions that I have listed on the first slide. Okay, so the first is the early project, which is really making use of deep learning models to predict students whether they need academic intervention in the upcoming semester. Okay, so how we have operationalized this is that we ingest data inside the educational data hub, we prepare the data and we anonymize it, which is then passed to Datahub, which is our data science machine learning platform, where we do further processing, analysis, and data modeling. And the results of the data model is then to our data visualization platform, ClickSense. So the interesting thing about this is that the early project actually started off as a PhD topic. Okay. So the model which was developed from this PhD dissertation was actually hosted inside Datahub. And if you're interested to find out a bit more about this, you can talk to Dr. Chiu Wei, who is there. Okay. So this is really a project. Yeah, we managed to actually operationalize it, scale it to 5 schools at the university. So it has a life beyond just being a paper publication, which we should publish quite a fair bit. Next is the skills project. We're at a very early stage of this particular project, but what we are trying to do is that we ingest curriculum data, so the course outlines and stuff like that, in the educational data hub, prepare them and push the data again to our data science machine learning platform, where we connect, use a Python script, right, to call the APIs to Skills Future and Skills tag all the courses. And from the Skills tag of all the courses, then we push the data to a SharePoint web applications to do skills validation by the faculty. And once the faculty has validated the skills, then we can make use of this information to come up with a ClickSense dashboard to allow program coordinators to visualize the data. And in the envision state of the dashboard, it will also allow them to say, oh, these are the skills that the courses under my program is actually developing. And this is what the industry actually demands. Okay. Once again, we have Joel, who is here, and he is one of the researchers in this particular project. Okay. Finally, I think that we are very similar to other universities. Okay, I'll speed up. Okay, we have other universities, like other universities, we actually allow enterprise level access to the large language models provided by the free cloud providers. And there are many faculty at NTU that has been working with us. So one of them is Leonard here, and Shian, and I don't know whether he's here. I think that he's online. We, by providing this, actually we can also conduct research around how generative AI could be used to improve teaching and learning. At the same time, we at Atlas, we also have that project to actually develop our own computing board. And the way is the person actually supporting that from a research standpoint. So finally, I come to my last slide. So I want to zoom back into the contributing and focus on the educational data hub. So for those of us who are in data science and in AI, I think you agree that the most important thing is the quality of the data. And the educational data hub is where give researchers access to the single source of truth. So we actually collate all the student learning data across many, throughout the whole life cycle. While it enables researchers to make requests for historical data while adhering to the university governance and policies and guidelines. So for those of you who are actually outside of NTU, right, you might be wondering, so can I get access to these data and so on and so forth? Perhaps one of the things that I was thinking about was that using some federated learning approaches, perhaps we can collaborate with other equivalent units such as ALTSET in NUS to enable a secure way of data sharing so that we can build and evaluate models together. So I've actually shared with you what a unit perhaps like Atlas. I'm sure that there are similar units over at the other universities, but they are operating in different models. So we provide AI and data services to actually enable research, development, and sustainable deployment. But then the key questions, as what Seng is actually saying, is that then what's the problem we want to solve with AI? Okay, thank you.
Good morning, ladies and gentlemen. Welcome to my presentation on understanding learner performance with the aid of AI generative data. So what is the problem we want to solve? So firstly, there are lots of research in AI in the education. Some of the common problems are how do we identify learners who are at risk of falling behind? Other problems can deal with what are the demographic factors that impact student learning. Because we have student learning by class, different classes perform well, some perform not so well. We have students within a class, in project groups, some project groups perform well, others not so well. So the question is, from an educational perspective, does demographic factors impact the learners? And demographic factors, especially let's say in the case of adult learners, could include ethnicity, could include whether they're married or not, could include whether they have children or not. So with these problems, right, we must know that we are looking at data that is sensitive. Student performance data, how they perform in the different components, assessments is sensitive. Demographic data is sensitive. When using AI technology, we have to be mindful that this sensitive data, one, can get into the wrong hands by some means, right? Two, we also face the problem is if we want to do the research, because the data is sensitive, we may not get access to the data, which means we may not be able to answer these important questions in research, right? And of course, the third one, the problem is that sometimes the classrooms are small, or sometimes you're going to do subgroup analysis, so the data sets are small. When we have data sets that are very small, it means that our AI technology, which is complex deep learning models, don't have sufficient data to learn the patterns in the data. And this is a problem. So I've outlined a few problems, 3 problems already, right? So the key thing is, and more importantly, is that when dealing with student data, right, it's sensitive. So the question is, we need to adhere and ensure that the data privacy, data security regulations are adhered to. So how do we do that? How can we do our research and still ensure that this data set is going to remain private and protected? Of course, we do have a solution, right? The solution is that we can generate synthetic data. So, of course, in your minds, what is synthetic data? Synthetic data is when we have the real data set, right? The student performance, let's say their demographics, etc. But now we want to protect that sensitive data. Of course, there are other means removing the sensitive data, but then your data becomes very light. If you're removing the ethnicity, you're removing whether they're married or not, we are not analyzing the complete data. And as we heard earlier, we need good data quality in order to get good results. We need complete data in order to make effective decisions. So by using the synthetic data, we're using all the data. We take the real data set, we have a model that generates the synthetic data. By synthetic data, I mean that we're looking at data that is very similar to the real data. We're generating data where each of the columns of the synthetic data is very similar to each of the columns in the real data. When I say similar, we actually validate our models by looking at the end results, where we compare the means, the medians, the standard deviations, the confidence intervals, all the metrics of the synthetic data we compare with the real data. And we ensure that those are similar by doing some hypothesis testing to ensure that these means, for example, are significantly, there's no difference between the two. So that's one thing we have to ensure, the metrics are similar. A key thing we also ensure by using generative adversarial networks is that the distribution of the data for each of the columns in the synthetic data is very similar to the distribution of each of the columns in the real data. And for that, of course, we use statistical technique called pullback Leiber divergence, where that score, the smaller the score, we know that the similarity is there. So generative adversarial networks is not new, right? And it has been tried and tested in several industries in generating the synthetic data. And also in education, it has been used. So this is a technique that I highly recommend. A third use case is the one where we said we have small data sets, and of course, your AI models cannot work with small data sets. Synthetic generation of data is another way of taking the real data set that's small, generating the synthetic data, and then combining the real data with the synthetic data to have an efficient sample size, whereby the AI model can find the patterns in the combined data set and allow you to make the decisions based on the outcome of your purpose of your model. So in a summary, in a nutshell, I want to highlight that firstly, AI models can be used when you have complete and quality data to make your decisions in the education field. And it's the students that benefit from this type of AI research because their learning performance can improve. So, for example, if you identify learners falling behind, you can proactively provide personalized learning, additional support to ensure they pass the course successfully. So that's one. So not only the students benefit, the educators also benefit too, because they can proactively learn and from the insights derived from the models, strategize and improve their teaching and ensure that their teaching is effective. And not only the educators benefit, of course, the educational institutions benefit from the use of the generative adversarial network, as well as the AI models, because the institution as a whole will have an outcome of more students, for example, performing well in their courses. So in a nutshell, I would say that why use sensitive data, or why do we run away from analyzing data using AI models? We should use the AI models. So we should use also the synthetic data, because at the end of the day, the data that we generate is no one's data. So we have zero risk. Even if the data gets in the wrong hands, it's no one's data. So we have zero risk, but at the same time, we have extreme benefits for the learner, the educator, and the institution. That's it. Thank you, everyone.
Hi, I think I have. Hi, I'm Shian, and I think I have 5 minutes, but I talk super fast, so it should work. So I'm from the computer science, and I'm actually one of the co-leads of the NUS AI Institute on hardware, software, systems trust. And so I'm going to tell you a little bit about what my group has been working in terms of brain sensing, and we're hoping that that could be something that could give you some insights in education research. Okay, the two big questions we would like to see is, can these AI-powered brain sensing wearables that we have designed and actually in startups right now, can that help facilitate novel education research? And then second, I'll have one last slide on the class I teach and some of the challenges we face. Okay, so first, I do AI hardware. So in almost all your phones, laptops, in the cloud data centers today, you all have AI chips that are in there. So Apple, Microsoft, every company you can think of is designing AI chips. And that's so that you could actually have fast LLM inference, deep models, I guess, running on your devices. Okay, so but today I'm going to talk about how these AI chips can basically power future wearables. So this is a particular my PhD student there, Boon. So basically, we looked at this problem like EEG. So you can actually buy some EEG headsets today, and I'll tell you some of the issues. So we have been working largely with NUH medical people, but I'm very interested because I like to work with kind of the education area as well. So in the medical arena, you basically have to use lead electrodes largely for the accuracy. And so that involves a technician, a trained technician putting on the gel on your head. So it's very cumbersome. And it does give you good accuracy. But what we're looking at is, could we have something like a baseball cap that you actually just wear on and you calibrate it just by yourself with your phone. And then in less than a minute, and you could actually walk around and get these traces. And so what we have got working, this is a video of our CAP, so that we've been working basically with, because with the healthcare people, they are looking at can we detect sort of seizure. And so when you actually have seizure, today it's not quite possible because firstly, even if you have this mobile EEG, you don't want to wear it for long because you need to have all those electrodes. And so with dry and with a baseball cap is something that perhaps students will be comfortable not wearing. So this is basically the secret sauce behind it. So what we did was we designed from ground up. So we designed from the electrodes. So if you see kind of the electrodes that are going in, so we designed them with some sort of special kind of electrodes that has a bit of pressure so that you could actually put on and off and still maintain good contact. And then we designed with a flexible PCB, which is a printed circuit board, so that allows you to flex so that you could actually wear it like a cap and still maintain contact. Because the biggest challenge is essentially the noisy data from your brain sensor. And then we house it all inside this, and along with that, there's an AI chip that will be connected to this board so that you could actually do processing and classification, because it's not quite useful when you get all those raw data. You basically want to be able to say, can we respond? Is the person learning? Is the person alert? And so on. So people today in industry, you do have products that basically like emotive. They're selling products that you can use for EEG, but we have centers in NUS that have been trying out many of the industry products, and they don't work well because the minute you have any slight shift in motion, it basically gives you very noisy data. And so the main research contribution here is that this can work even when we are walking and running. And so we have actually tried cycling and running as well in our user accounts. And so, and then as a platform for starting that, this is the class I've been teaching ever since I returned to NUS about 6-7 years ago. And what we found is that this is a class that clearly requires a lot of mobility. It has, so what I teach is a capstone project class for the computer engineering students in NUS. And groups of 5 come together and build basically a laser tag system, but it's an augmented reality laser tag system. So they have software, they have hardware, and they work in a group, which is very hard to virtualize. So during COVID, we are like the only class that actually came to, even during lockdown. And so we just wore masks and we kind of like social distance and so on. And so what I thought was, I'd like to see if this could also be a platform for challenges in how do you design classes where it's so hard to virtualize, but yet you still want to detect their engagement. And so EEG basically has a way to, I think, directly measure how focused you are. So even if you're measuring your eye gaze, you may be sort of glazing out. You know, my kids today, they just stare at the lectures and they're not listening. But with EEG, you kind of could actually measure their attention. You can measure things like drowsiness too, alertness versus drowsiness. You could also measure things like anxiety, so stress. And so these, we thought could be something that's useful for educational research. That's all. Yeah, thank you.
Hello. All right, good morning. Originally, you weren't meant to get me. My colleague who was supposed to speak is very ill, right? So I will take this time to talk a bit more about what NUS has in terms of the capabilities similar to what NTU Atlas is doing. I must say that I didn't realize they're talking about it, so we're not trying to compete. Just so happened that I actually run this center called the Center for Education Technologies at NUS. The center started during COVID, right? The point was that government wanted to invest in during COVID, like in things that can position us better when we actually get out of it, right? So this was set up, okay, and the kind of principle that we are set up based on is, okay, I was MOE for 5 years, and later on you hear about SLS, which I sort of oversaw until 2016, right? So the MOE focus is actually on teachers, that the teacher is the heart of the education system, not technology. So I will emphasize again the focus today, even though it is an AI workshop, right? So the innovation education, our view is that it is not so much a tech problem, it's actually a pedagogy problem, right? So my center adopts what's called pedagogy first approach to building software, right? We figure out what the teachers want to do, and then we do better. Okay, instead of replacing teachers, the kind of high level goal is to build this Iron Man armor thing to help them do better in different ways, right? So that's the high level thing what we do. What we do is we look for problems that teachers care about and are important to education. We try to build something that hopefully works, then we out and teachers, right? So one reason why this I decided to make this presentation is because Hui Mei, my colleague from A-Star, also mentioned yesterday that there are one of the problems that researchers face is really how do you get your ideas out there, right? Because it's hard. Okay, so how do you validate our work that actually works? Okay, so how we do this is that it turns out that I actually control or built this platform called Cosmology in 2013. Okay, it's many years. Okay, I currently have 23 schools, MOE schools using it, and I have about 2,000 MOE students using it. So far, we have about 11,000 students. Actually, it's more than that, but this is a bit old numbers, but we have this. NUS, I have 27 courses using it, 5,500 students annually, but so far, about 25,000 students used it. So, and apparently, Young Qualitative is using it also. Okay, the reason why people use my platform is because why not SLS? Okay, because very simply, my platform was built to teach programming, right? I was overseeing SLS. Okay, why does SLS not do it? Well, very simple reason, because the enrollment is very small. Okay, SLS supports 500 million students in the whole system. Your total enrollment of programming of students only programming like 2,000. So MOE, in terms of the greater scheme, will not invest money to build something for 2,000 students out of 500 million, right? Okay, so that's why my teachers are here, and also I'm also the instructor for 70% of the sales teachers, or 100 of them. Okay, so they are my students, so they use my platform, so that's how it works. So basically, I have control of a platform which has real students. Okay, and I can show the demo of what we have done so far. Oops, my slides working. Video working. No sound. Okay, so how do you this for me? Okay, then I know this sound. I thought. Okay, so basically this is my LMS. So you write code, students write code, submit code, right? And normally what happens is that I have human TAs that type in comments for them. So basically the code is wrong, okay, but it's not good enough, right? Okay, but human TAs are expensive, right? So we have built a system called Codeberry. What it does is that it's a service whereby you send a code to the server. Okay, you will generate all the comment feedback for on a line by line basis. So now as a TA, what you do is just check whether the comment is correct. Okay, amend it, and then you post it. Right. Why is it necessary? Because we use LLMs are actually using GPT-4, which has this nasty problem called hallucination. Sometimes it's wrong. Nothing we can do about it. We just try to do prompt engineering to fix as best we can. But ultimately, that's what we do. So this system basically essentially gets feedback from our server and gives feedback to the students, and then you just check and post. Okay, so that is more or less how the system works. Okay, now and then we are also interesting, and NTU is building AI tutor. I'm also building one. Okay, and a really cool demo. I can show you later. Send the link. Okay, but basically we are building a sort of automatic AI tutor, right? And the key idea is actually to okay, this is not the right slides, but the key idea is actually it's not just about tutoring. It's actually to try to mimic the effective parts of teaching. Okay, and as the NTU colleague, I forgot his name, he was mentioning after COVID, these kids don't even turn up for class. Okay, so how do you engage students that don't even physically turn up? Okay, so we're using Telegram and doing all sorts of things, right? And then this thing, I don't know how many people want to complain about this, but since ChatGPT came out, it's a disaster. In the past, they cheat and know they copy code, can catch them. ChatGPT, it turns out we can't catch it anymore because they generate different versions. Okay, it's very hard to catch. Right. So basically, what we have at NUS is that I have this system which I have basically 7,000, 10,000 students annually back my luck. Okay, using it for real. Okay, we have actually integrated this thing called Codeberry. Okay, so it's actually integrated. If you go on the platform to teach coding there, you enable it, you can actually use it right away. Okay, and now we are on trials with the teachers who are my students. Right, and then actually it's also integrated with Fruiter, which is the system used by IIT Bombay and Kanpur. Okay, and because the guys working for me, they came from their PhDs from that school, so we have integrated with 2 LMSs. Okay, and that's why we have feedback. We have actual real student data. Okay, in this systems. We publish a few things. Right, Chico is a new AI tutor thing that we're building. Actually, we should be trialing in next month. Okay. And then SSID is the prediction detector that we're going to build soon. So interestingly, the way it works in the architecture is that there's a mothership, okay, Cosmology, which is the LMS, right? And now obviously we have built capabilities to allow external applications to kind of integrate with it, so that whatever is developed can actually go live. Okay. Yeah. So let me just quickly pause to say something which I thought earlier, which is that we have invited Boon Leong from MOE, as Seng mentioned. Now, Boon Leong, where are you, Boon Leong? Boon Leong, right? Yeah. So he is here because he is a member of the SLS team. Okay. So one of the things that's important to this whole discussion is data, right? So Boon Leong will be talking about what data will be available. I think they did a workshop for NIE recently. Okay, so most of you are probably not there. So this is important for you to understand that. But more importantly, MOE, okay, also does this thing called commission research, which means that they will have this research grants that are normally given to NIE people, right? I was on a panel before. Actually, it's like, don't approve what, I mean, really, cuts and stone, really, you're going to give money to them. Okay. So one of the things that Boon Leong will be doing today, right, is to actually give a preview. Okay, it's like inside story, yeah. So of what MOE is interested in terms of the research problems, right? So I think one of the important things about this whole workshop, I think Shih I hope to get out of it, is also a kind of a local context, right? So hopefully the speakers today will also give you a sense of what are the research problems that are also relevant to Singapore. I think one of the important things about the white paper is not just about education in general, but also the Singapore context. It turns out, I mean, I've been around for a few years, I've been 5 years. Singapore, for better or worse, we are actually very advanced in the general scheme of education, right? So actually, many of the things that people do are not quite applicable to us because we already have a lot of resourcing. We have a different system from many jurisdictions. So I think it's important in this whole discussion, right, to also keep this in mind. All right, yeah, that's what I have. I guess I'm done. So next would be, I think Nancy will go, and then finally, last but not least, the most important actually, the SLS team. Right, so can you put your hands together to welcome Nancy from ISTA?
So, good morning, everyone. Can you hear me? Can find the slide. Okay. Hi. Yeah. So, yeah. Today, I'm very happy to have this opportunity to share with you research that I've done in my program, AI for Education at A-STAR. So we're also a pretty new program. We started this year to consolidate all our efforts that we've been working on using AI for education for quite a number of years already. So in particular, I'll have more of a focus on the multimodal, multilingual generative AI research that has helped with our education applications. I also double hat as the generative AI group leader as well. So since a lot of you, I might be new to a lot of you, so this is just a brief intro to myself. So I'm actually quite active in the AI scene internationally in the research part, but also in addition to research, we also are interested in translating technology for both government and private sector deployment. And so there are a couple of commercial spin-offs that came out as well. And so over the years, I have learned a lot from colleagues like all of you, whether it's in the private or public sector, to transform my thinking of, when you're only thinking about AI research itself, you might only think about publications. But when you want to make those research work for the real world, then a lot of other nitty-gritty details, the devils are in the details that we really need to think through. And I'm really glad to have this opportunity to learn from all of you. And also a lot of what you all presented so far has been resonating a lot with what I've been doing and thinking. So yeah, so here, so what I'll be talking about will relate to some of these projects. So we have a couple of projects related to AI for education. The first one is the AI and Education Grand Challenge. So AISG put this out. So this is to solve the problem that While we have 4 official languages in Singapore, the mother tongue language usage in the household has been dropping steadily for the past 2 decades. So if we can use AI to fill in this gap, so that children that have parents that don't speak these mother tongue languages are not confident in them, there's still ways to extend this kind of learning for young children outside the classroom. So this is one aspect where we're working together with NIE, NTU, and NUS on this. My colleague Wei here, she's a PI for MOE Science and Learning grant. So this one focuses on math learning and teaching, so especially focusing on the weaker students, how we can use AI to help them. And so different things we're looking at include language models, knowledge tracing, and also education studies, whether it's inspired by AI or theory. So this is a collaboration with NIE colleagues. And then another one is focus on oral literacy and we start with English first, where we focus on how we can give self-solicit feedback so the student can learn on her own or his own more. Yeah, and then there's been some deployment in the private and public sectors. So this slide resonates some with the previous slide, but basically our experience has been applying AI in the personal learning sense for languages, math, and sciences. And another thing that we've tried to embed into our AI technology is a more scaffolded learning concept where you don't directly feed the answer, but you try to guide, the AI tries to guide the question generation to encourage the student to reflect better. And so then this is more adaptive and personalized for each student. And so in our program, AI for Education, so we have these 3 pillars of research where we try to help support the teaching, learning, and assessment of the education practitioners. So one part is from the more of the back end of content augmentation. So how we can use AI to maybe make more resourceful curriculum design. And also in the private sector, a lot of times they have material, but they don't know how to automatically manage it in a more resourceful manner. So they have different learning objectives or they want to generate new questions. So we use AI to help them, and this led to a spin-off. For the students' learning journey, we would like to use AI to help inspect the student responses and progress to trace their knowledge states and also potentially envision how assessment and evaluation outcomes will be like, so to prepare for that. And a lot of what I'll be talking about is in the 3rd pillar of interactive technology. So I guess this is a lot of the work is on the first part of AI tutoring for students, especially for younger children. But a lot of the technology, we have also had partners use it on adults as well. And it can be expanded for mentoring and coaching. So next, I'd just like to show a demo of how we can apply generative AI to speech to make the technology more personalized when students are learning how to read. So here, I'll show a student's recording first. And students might make mistakes. And so instead of explicitly telling the student you're wrong all the time, here in our generated speech, we would highlight the word that was mispronounced and make it more articulate, make it slower, so that it's easier for the student to absorb this word in a very subtle way. So I'm not telling you you're wrong, but acoustically, this word is more salient, so it's to help self-correction. So let's hope the technology will work. A lot of times it doesn't work when you want it to.
So the North was bleached to confess that the sun was the stronger of the 2.
So this is a secondary school student. His English isn't his strongest strength. And so he made a mispronunciation in obliged. And so here would be a standard reference.
The north wind was obliged to confess that the sun was the stronger of the 2.
So here the idea is like you have a speech highlighter. So you all used it for text before. And so now I know this word, it's easy to make a mistake. I highlight that part of the waveform. And so that automatically, after I detect the mistake, and then now I can generate.
The north wind was obliged to confess that the sun was the stronger of the 2.
Right.
The north wind was obliged to confess that the sun was the stronger of the 2.
Sorry, the first one was wrong. Did everyone hear it? Should I play again? Yeah, so oblige was more clear and articulate. So this can also be applied to Mandarin. So oftentimes for Singaporeans, this could be a problem, especially if it's a Z or ZH, right? So if your tongue should roll back more. So let's listen to a sample.
The north wind was obliged to confess that the sun was the stronger of the two.
So here the last syllable was wrong. It should be no ZH, it should be Z. And so this is often hard for many people. And so the standard reference. And then here we want to highlight the last syllable to make the students self-correct. So yeah, so this is our speech highlighter captain. So it's one way to make it a little more personalized and make the student respond better because no one's telling you, oh, they're wrong. So another thing, so this is from the AI in Education Grand Challenge where ASG is a grant for. So here we developed these multimodal Gen AI tutors where the tutor is able to do a scene understanding on a given picture. And then afterwards, we can have a spontaneous and personalized interaction with the AI tutor. And so it will scaffold the question generation instead of directly saying, oh, you should talk about this. All right, so try to elicit the student to express himself more, especially these are young children still learning how to grasp language. So let me try to play this.
Let's take a look at this picture together. Can you tell me what the people in the picture are doing? Yes, they are having a meal. Can you tell me what kind of meal it is?
Family gathering.
That's a great observation. They are having a family gathering. Can you see what's written on the wall in the upper right corner?
I don't know.
That's okay. Let's look closely at the wall. It looks like there are some decorations on the wall. Can you guess what they might be?
I don't know.
That's all right. Let's think about what kind of decorations we might see during special occasion. Can you think of any special occasion that's coming up soon?
I don't know.
That's okay. Let's think about what kind of decorations we might see during a special occasion that's coming up soon in China. Can you think of any special occasion that's coming up soon in China?
Chinese New Year.
Yes, that's correct. During the Chinese New Year, people often decorate their homes with red lanterns. Can you see any red lanterns in the picture?
Yes.
Great. Now, let's summarize what we've seen in the picture. Can you use 1 or 2 sentences to describe the picture? Remember to include what the people are doing and what decorations you see.
So I'm going to stop there since we have some time constraint, but here is an illustration. And so we talked a lot about data. And so we also tried using synthetic data before, but before that, we listened to the real data. And oftentimes I'm told, Nancy, we have so much data for you. And I go, look. And in this language learning context, if you don't know how to speak Mandarin, if someone is talking to you in Mandarin, you're expected to reply in Mandarin. What do? You're a kid. You don't talk. So I get a lot of silence. I'm like, oh my God, half of it is silence. Then finally, the child talks. He says, I don't know. In English. I'm like, okay. So then sometimes they say, 我不知道. You're like, oh, finally, I have 5 words in Chinese. So the data is quite precious, but this makes us realize, when you design the AI, you should really think about who's using it. So a lot of times, even though we've been in this field for a while, we forget because we're adults. And then we're like, okay, yeah, so we will respond this way and that way, and we'll have these mispronunciations, but actually, when you really need help with the language, you don't talk or you just don't know how to talk, because these are very young children. You give them a picture of a lot of things, they don't have the experience of how to navigate it. So then you need to let the AI know how to guide the child. And in this example, I realized this works better than me when I teach my children, because I'm not this patient. I'll be like, oh my God, don't talk to daddy. Yeah, so this is actually one good trait that the AI has. It can be very, very, very patient. So, so this is some of my own professional and personal experience. And then now, actually, I was talking about we're using this to teach mother tongue, right? So I'm going to show an example where we're using it for Mandarin. Okay. Yeah. So, can I just have a quick show of hands? Who understands Mandarin here? So quite a lot. Do you feel comfortable teaching your own children Mandarin at home? Yeah, a lot less. Yeah, so now we're thinking, okay, we'll use an AI to help us. So then this is still work in progress. So I'll show it around, and then we can discuss a bit about it.
一起来看出这张图片吧。首先看看图片右半部分，你能描述这个家庭在做什么吗？
在吃饭。
对，他们正在一起吃饭。你能告诉我他们正在吃什么样的餐食吗？
吃火锅。
好观察，火锅是中国最流行的菜肴之一。现在要看图上右上角，你能看到墙上挂着什么吗？
我不知道。
没问题。 看看物体的形状和颜色，它们像高楼一样，不对吗？
你说的对。
太好了！灯笼经常用于节日装饰，比如中国春节。你能猜猜这幅图片中的什么节日正在举行吗？
中国春节。
So yeah, so I'll just stop here, and I'll quickly talk about some issues I've seen. So one is, although the speech is in Mandarin, some people tell me the accent is not suitable for standard Singapore Mandarin. But actually beyond that, the syntax or sentence structures used are sometimes pretty westernized. So for example, the AI tutor said 好观察. Good observation. So in English, that's, common, but in Chinese, no native speaker will tell you that, okay? The other is the sentence structure of like tag questions in English is supposed to be suggestive. Oh, aren't these red lanterns? Is it? So these tag questions, if you convert it to Chinese, it could feel like you're scolding someone. So these are not really suitable in the context of teaching a language, and we need enough nuanced understanding when we do this, because we may not think we're good at Mandarin, but if the AI actually underlyingly, the technology is flawed, it could also trigger a lot of problems. Yeah, so so here I want to bring you to this point where we also did some systematic study where we looked at the closed source and open source large language models, and we made one difference. Okay, so these are multiple choice questions. And then we have different ways of instructing them about the multiple choice questions. So please choose the correct answer from the options provided in the multiple choice question, or please select the correct answer from the multiple choice question. To a human, these two instructions are exactly the same. And the question answer attached afterwards is exactly the same, but you just change the instructions wording, then the answer is different. So we did this systematically, and that is what we observed. So there's a lot of variation. how about I change the language? So for example, here's a physics question in English. Then I use the exact Chinese translation, Indonesian translation, Spanish translation. Then they cannot get it right. Okay, so these are some qualitative examples. If you look a little deeper, so here I want to say that usually we think, ChatGPT is so good, so 99% correct. But actually, if you do a more systematic investigation, that 99% point actually should be decompressed to something like this, where now this, or even more complicated, but now I'm only showing a 3D kind of representation where one dimension is the semantics, where you paraphrase instructions like what I showed you. So there are instructions that semantically are equivalent to a human being. And then on the other axis is the different languages, and then the vertical axis is the accuracy. So I don't get one dot, I get all of this. So I get different planes for each language, and none of them are flat. So you see green is on top, but it's not flat, okay? And then there's a big gap to the red one, which is Mandarin, and then Spanish, Indonesian, Malay. So this is in reality what we get. So when we're using this technology, we should be pretty careful. And for us, we're also developing the large language models. So these kind of investigations and how it's used in education inspire us to realize, oh my God, the representation underlying, we really need to make sure we're doing the right thing in machine learning. Yeah, so I think this one I'll skip. This is just another example on if we use AI tutor for science subjects, and it's a little similar to before, but here you need to give a little more domain knowledge and explain to the child in different ways because the child may not understand so well. So this is just another example. I will skip this. And then related to when we apply it for science and math, so here I just wanted to show another type of thing that we did is the question materials come in different forms. So in this case, there is text with a table with some images. And a lot of times some of the players in the ecosystem, they have these resources, but they don't know how to tag it to the learning outcomes. Or it's very tedious. So we've helped them automatically tag it. And then you need to understand the multimodal input and also sometimes even generate these questions so that they have a wider set to be validated by teachers. Here is another example where we say, oh, we can use large language models to help. And so when we investigated, we realized large language models in humans can make similar mistakes in mathematical reasoning. So in this case, all these different numbers embedded in the math question, they might have different units. So here the unit could be dollar or dollar per shirt, but the language model and the child may not realize that the units are different. So here we could build models to help identify them and do consistency checks to make these tools better to use. And we also did this for logical reasoning. And then a lot of this helps contribute to knowledge tracing, where we can predict students' performance and integrate natural language processing techniques to understand the question better. And this is Wei-Mei's work. Okay, so here I would like to show a very, very last example. So we're also working on the National LLM program along with AISG and IMDA. And for our part, we're building a multimodal AI that can understand English, and it's called Lion AI. And so here, we're gonna give this AI this video, and then we're gonna ask some questions. And then hopefully can inspire us on how this can be used when we are thinking about teaching, learning, and assessment. So I'll show this video.
You said today, as you often say, that you live in Singapore. Of what nation are you a citizen?
Singapore, the best country in the world.
Are you a citizen of any other nation?
No lah, you cannot have citizenship of another country. Only Singapore citizen. You cannot have more than one citizenship in Singapore.
Have you ever applied for Chinese citizenship?
Apply for Chinese citizenship for what? I'm Singaporean. I love being Singaporean. I'm Singaporean right down to my pants, to my underwear.
Do you have a Singaporean passport?
Every Singaporean have Singaporean passport. We love to travel. It's the best passport in the world. We can always fight with Japan for top spot. We can go to many countries. Best passport in the world.
Do you have any other passport?
You cannot have more than one passport. Singapore passport only. Allow it. Inside.
Have you ever applied for American citizenship?
Apply for American citizenship for what? I'm Singaporean. I'm happy to be Singaporean. Allow it.
Have you ever been a member of the Chinese Communist Party?
Chinese Communist Party? Crazy or what? I'm Singaporean. Apply for what? The only party people like is Sentosa Home Party.
Have you ever been associated or affiliated with the Chinese Communist Party?
Hey friend, do you know what Lee Kuan Yew did to communists last time? Why would I want to associate myself with Chinese Communist Party? Siao.
Let me ask you some hopefully simple questions. You said earlier, in response to their question, that what happened at Tiananmen Square in June of 1989 was a massive protest. Did anything else happen in Tiananmen Square?
Hey, Senator, why are you asking me this kind of thing about Tiananmen? History lesson. What's that got to do with me? I'm a Singaporean who happens to be Chinese. You think what? The whole Singapore is Chinese? You think just because I'm Chinese, I'm from China? You think the whole Singapore is from communism? You see or what? This is a dumb question. Are you even a real senator? Have you ever been a real army ranger? Tom Cotton, you never come to Singapore before, man. I thought you did. You should know we are a multiracial country, what? And we are not part of China.
So now I'm gonna ask the Malayan AI question.
According to the Singaporean individual, why is Singapore a good country?
So it can answer and so distill information from multiple rounds of social question answering, which is summarize. And then, so this is actually a conversation between a pretty heated, two parties. They both have different perspectives. So I want to check if the AI can understand.
Can you insert the Singaporean king part?
So it is able to tell the Singaporean and Tom Cotton have different perspectives and articulate what the Singaporean Mr. Brown's perspective is. And then the next one is contextual understanding. So
towards the end of the video, when Tiananmen Square was mentioned by the American senator, how did the Singaporean react?
So here, as the video progressed, Mr. Brown became more and more agitated and frustrated towards the end. So here, our Malayan AI is able to understand and contextualize this. But now I'm going to ask a slightly different question.
Why do you think the American senator brought up Tiananmen Square?
So both questions about Tiananmen Square, but the first one you can leverage on the context within the video to answer the question. In this second one, I'm not very happy with our Malayan AI's answer. And so this is still work in progress. We're still making it better. So here what the problem is, it wasn't able to grasp the wider context of the geopolitical tensions between USA and China. And so a lot of things are at play here, right? So the TikTok CEO is a Singaporean citizen of Chinese descent. So Tom Cotton, the American senator, was kind of muddling the waters because there's a very nuanced relationship between national identity, ethnicity, and cultural implications, right? So, so these are things that what the AI can and cannot do now. And as an AI researcher, I'm trying to make it better. But then as an AI researcher interested in education applications, I think this opens up a lot of opportunities for us of how we can leverage on generative AI development to further how we teach and learn and do assessments. And in this process, I've learned a lot and hope to learn more from you today. Yeah, so I think I'm running out of time, so I'll end here, but looking forward to have more engagement.
Right, good morning, colleagues. My name is Boon Leong, and I'll be sharing about how we can use SLS to support educational research. I understand that the time is a bit close to your break time, so I will not hold you too far back. So I'll just make this a quick one. Basically, there's just two parts. The first part is actually to provide some context for you all with regards to this data that you will be interested in, because I think it's quite different from how you all do or use your learning management systems in your higher ed. So let me do that. I will skip the video. I will just share a little bit about for SLS, right? What we actually like to do is as what Ben has mentioned, we actually put the teacher at the center. And very much as what was mentioned earlier, we want to develop students to be collaborative. We want them to be self-directed. We provide personalized content for them as much as possible. And also we want to be flexible so that we support various modes of learning within the schools itself, right? Now, we have actually moved from SLS version 1 to version 2. Some of the things that you all mentioned about using AI, we have actually incorporated it within SLS itself. So just now what you saw with regards to the speech evaluation, where students can read in and can provide kind of highlights as to where did they read wrongly. Yeah, all these are currently within SLS. And another very interesting thing that we're also using our large language models for is to use them to generate lessons within SLS. That's upcoming in June, so you have a slight preview about hearing about it. If you want to find out more, I suggest what you can do is go to Google, just type AI in SLS, and you will see the whole tutorial of features that we have. Okay, I don't have time to share more here. Now, very importantly for SLS, what we do other than when we support the learning, we support two modes. One is in-class, the other is home-based learning. So a lot of the features that we do are used by teachers within the class to conduct lessons, be it to answer short quizzes or for them to access the material. And the tasks that we give to the students are two types. We can give them homework. The first one, teacher assignments are like homework. The second one is there are basically lessons within SLS that students are invited to go and explore on their own. They can explore even up to grades that are higher than their current one. So this is very much a feature for us because we want to develop self-directedness within our students. Now, with regards to the age group of students, as what Ben has mentioned, we have about 500,000 users, range from P1 to JC2, okay? We also have students who are in SPED schools, who are on leave of absence, and we even have students who are young overseas Singaporeans who use our SLS system, right? So that they can keep up to date with the curriculum while they're overseas with their parents. Okay, now this one will be a bit more interesting for you. I think for us, with regards to our infrastructure, with regards to the data, we have actually the usual database, and we have the sandbox. The sandbox is something that you all might be interested in if you would like to pilot new applications that integrate within SLS. I think like what Ben was mentioning, there are certain use cases that are unique to certain groups of students, and we might not necessarily develop them, just like the computing app that he actually had. So for some of these, we actually encourage developers to try out on the sandbox before actually integrating within SLS. We are also very excited to talk about the learning record store because that stores the learning interactions between the user and the system. So they are stored as API statements. And actually we have them and it's actually up and running. Okay. So how we can use SLS to support educational research. So we built it as an open system. We have core features and we have core resources. So because we use a modularized approach, right, we can actually open it up to our users to access a wide variety of resources and features. So currently, right, how we can allow users to access them is through whitelisted apps or integrated apps. Whitelisted apps just simply allow the teachers, when they create the lesson, to actually embed it as an iframe within the lesson itself. Integrated apps could be integrated through our LTI 1.3 capability, right? And what we would like to do also is in future, we're going to develop this SLS marketplace where teachers will be able to look through the system and see what are the available external resources as well as whatever there is in the app library for them to use. Okay, so if you're interested to build them, we are more than happy to have a conversation with you. Now, the next thing that Ben was talking about, the ERFP, Education Research Funding Program. Now, so for those of you who are interested to tap on this and you're building applications, the key is to see if there's any existing features already so that you try not to duplicate. And if there are things that are new, our suggestion is that you can actually work with us, have a conversation with us to see how you can actually whitelist or integrate these tools within SLS. So as I mentioned earlier, you can apply for a sandbox environment. You can go inside and play with it and see how it might actually work for you, right? Now, the next thing is the data dictionary. Yeah, this is the one where the kind of data that we have within SLS that you might be interested in. Now, if you go to Google once again, you just type SLS data, you'll be brought to this site and they will tell you more about the data as well as the PDF document that actually talks about the different data types that we have, right? Now, if you want to access this data as part of your research, first is if you happen to have a MOE point of contact, that means someone that you work with within MOE or division, please get them to write to us. They will know who to contact. Second, if you actually have a research interest, you can actually do a collaboration with the X Lab. These are a bunch of my divisions, senior specialists who have different areas of interest. I will show you later on. Yeah, or if you are interested, you can also write directly to SLS office to this particular link and tell us what are your interests, and we can see we can do a meetup, right? Now, one of the key things that I just want to stress is that because data extraction costs, and so the priority will always be given to MOE initiated or commissioned projects, okay? Because there's always money involved, so we have to do some prioritization. Last but not least, there's also the surveys through SLS. We can also conduct surveys through SLS. The good thing about this is that it reaches all these students. All students in Singapore have access. And the interesting thing also is that we also support a variety of question types such as these. And they allow you to also upload file attachments. So all this could also better support your educational research. The last thing I wanted to say is about the collaborations with ETD. Now, just now I mentioned there are 3 ways you can access the data. One is if you contact a division within MOE, or 2, if you have a research interest area pertaining to any of this, right? You can write into this particular email here. We will let you know who to connect with, those specialists who are specializing in these areas, and you can have a deeper conversation. The third, if you choose not to do any of the first 2, you can write directly to the SLS partnerships email, and then we can also connect there with you. All right. So I think I will bring my presentation to close. Right. Thank you very much. Yeah.
So as technology got integrated, right? Any user in the system can use it. Is the sandbox capability of SLS equivalent? Is that if the researchers,
Yes.
Inside, right?
Yeah.
Any of 5,000 students can use it.
Okay, sorry, this one I would like to say the sandbox, right, is not the same as the one that the student use, which is the production. The sandbox is like a separate environment. There are no students on it. Yeah. So if you want to use it for research or anything, then what happens is that whichever the students or whichever users need to be given an account to go in. It's a separate one from the one that the students use it for lessons. Yeah.
So it's a bit annoying.
Yeah.
Not my vision last time.
Okay.
Yeah.
Okay, thanks.
Any other questions for Ben Leong?
Thanks a lot for all the presenters. There are more questions than the answers, but never mind. I think basically, I think this presentation is some ideas for us to figure out discussion later on. Before we go for tea break, we'd like to announce the groupings. Okay, now these are not prescription. You are free to choose which group you want to go to. These are based on your survey. Okay, so we sort of assign the groupings, but you can choose to go to them. So we will have 2 groups looking into new methods of teaching, learning, assessment in the era of generative AI, because there are many people who want to do this. Okay, so the 2 groups will be there. 2 tables on my left. Okay, and the facilitators are Lina, is it?
Lina and Carol.
Carol. Okay. 1, two. Okay, so the one on the left. The third group, AI for neurobiological methods for understanding learning. Okay, this is the group in front, in the middle. Okay, we still have a lot of space for this group. This is interested in this group and by this group. There are about 10 chairs per table now. You can put in more chairs if you like to. Okay, but let's try to distribute around at most 12 per table. If not, you won't have a chance to speak. Okay. So two groups of new methods of teaching and learning, that's again. Okay, and then this group will be the neurobiological methods of understanding learning. And we also have new methods of studying teaching and learning. That will be the middle table at the back there. So again, these are some of the tentative arrangement for some of you to go there. But if you want to go there, another group, feel free to do it. Okay. And one more group here on my right, first group here, will be AI supporting lifelong learning and knowledge creation. Okay. And these two groups, I think, new methods of studying teaching and learning will be facilitated by Siong, and this group, Alwyn. Okay. And we have one table left. Okay, on my right, last table there. That is for anybody who wants to start your own topic. In case you're not interested in any of these topics, you want to come together to talk about some of your own ideas, okay, feel free to do it. Go to this group here, and then we'll be facilitated by Jonathan. Okay, Jonathan will be there. Okay, so we come back around 10:55, or you can just grab your key and come back here. Okay, so we'll start around 10:55, and then the group will end around 12. So we have one provider, right? Yeah. So don't eat too much of tea.
Sorry. Each group, before you all break for lunch, right? We will eat. No. After you come back, okay, sorry, I'm going to break for tea. You come back by 10:55, right? To talk, right? Then by 12, we break for lunch. But don't be so in a hurry to wrap up the lunch. But because after lunch, still have to work. In Singapore, no free lunch, right? Okay. So before you break for lunch, can we also request that each group, right? Volunteer or arrow somebody who will be, all excited to present the findings to your group, lah. Okay. Don't please, okay, the facilitator. Okay, sorry, just make sure we are on the same page. The facilitators are there to help you with the facilitation. It is not a necessity for them to be presenting on behalf of the group. I think each group should decide who is most comfortable. But before you break for lunch at 12, right, you need to also decide on who will actually be presenting on behalf of the group after lunch. Right. Thank you very much. And I'll thank Hans again and for arranging for our tea breaks. Right. Thank you. Okay. Hello everyone. Can I have attention quickly? Okay. We need to wrap up the session, right? Okay, the presenters who want to use PowerPoint or present, right? First of all, the Wi-Fi that you can use here is create guest, right? Password is create capital C, okay, small underscore tower. Okay, so this allows you to log on into the Wi-Fi, and the Zoom link is actually what's Zoom link? Yeah. So how are you gonna do? What? Not so bad. It's okay. Can.
Am I blocking anyone?
Sorry, give me a second. Type out this thing.
I'm actually quite short. So you are right at the center of the display. The camera is here.
So they're looking at you.
Are they looking at this? They're looking at you. Oh, it's literally
To say hi.
my big face. No, they can look at Ben now. Yeah.
Okay, the Zoom ID is as shown here, 821-6836-2144. The password is 561989. Okay, so the presenter who wants to use the projection can use this and then project share screen. Okay, and you will be able to do that. Okay, without further ado, I guess we can start lah. We will start in order of the group lah. Group one. Group one is the group. Okay. Who is the volunteer or volunteer? Are you going to do? Can. There's a mic.
Oh. Turn. I think that helps. Oh, no.
Okay. Okay, go ahead, Sarah. Okay, so thank you, everybody. So first of all, I just want to talk a little bit about a discussion revolves around several themes, but keeping at this moment of time, we start off with clearly identifying and knowing that you are three players here in the game, right? You have teachers with students and the AI is coming to play in this thing. Some of the major questions that we had was basically revolved around discussions about how it affects agency, right? Especially in terms of both teacher and student agency. So in this case, there were some discussions on how, in terms of new methods of teaching and learning, in terms of this, how does AI assist and augment teacher agency or student agency without, for example, compromising on the kind of responsibilities both teachers and students have when it comes to teaching and learning processes. In this case, one of the things we also identify as one of the difficulties which we don't know very much as of yet is how then does, for example, the use of AI actually can help deal with some of the motivational and affective issues that we see happening in the classroom. We can see that happening more closely in terms of some of the solutions that are being proposed dealing with the cognitive aspects of things. I'll come back to that a little bit later on. But I think when it comes to motivational and aspect and affective issues are question marks that we still currently have. Does AI actually help, or doesn't AI may not help? In this case, for example, perception that an AI is teaching me versus a real life human is teaching me, how does it affect my motivation and my perception towards those responses that are given to me? But I take, even though the content can be the same, will the perception that a bot versus a real life person actually significantly differ and therefore result in different learning outcomes as a result of them, right? Now, other than that, I think one of the key things, obviously, that we have talked quite a little bit about is how essentially AI can be utilized to actually give much more detailed and step-by-step guidance, especially in issues and teaching that actually requires much more specific kind of feedback and that will help in terms of learning. That can be done still in small classes right now by humans. The issue is with larger classes that then becomes an issue. So we do see potential of AI doing that. The key issue, however, is to clearly be able to boil things down to the different aspects in terms of critical skills and critical knowledge that can be broken down into step-by-step so that this can be done. That, however, is a pedagogical issue, which we realize that depending on who you talk to and depending on the discipline that we're looking at, some disciplines have an easier job in terms of identifying these are exact things that we need to do. Some are not so clear-cut, right? So that's one of the things that we discuss on. The other things that we have discussed on is basically, in the end, what we do want is basically in the area of getting students to be much more engaged in terms of this particular process. Engagement is one of this. Engagement in terms of which areas, key things that we talked about is basically, can we engage them to actually reflect a little bit more at the metacognitive area where, again, used appropriately, can AI then come into as part of the learning process, especially now where much of learning is actually done at a blended level. At what point can we use some of these tools to actually get students to actually check back and understand, actually, are they really learning or are they simply having an illusion of learning? Where essentially just look through the entire video, they felt that they have learned well, they're highly engaged with the video, but actually at the end of it, they're not really learning well. How can AI come in to actually bring them to the levels to check for understanding, for example, right? Our cognitive level, I think, is something that we talked quite a bit about, and I think it's intuitive for most of us, so I won't focus too much on this. There was some questions that we had in terms of both affective and social aspects of learning. We realized that actually quite a lot of our learning, especially when it comes to things that are relatively complex, where there isn't exactly a clear answer to what we are looking for. For example, like what we are doing right now, we rely quite a bit on social aspects of learning, where we're learning from each other. To what aspect does, for example, AI come into play, and can that be a critical role? It's something that we're still trying to figure out. We didn't have a clear answer to that, but that was a question that was asking. The other one that we mentioned is this. It seems like human teachers, as a critical aspect of education,
actually plays a large part in actually managing and affecting student motivation in terms of the effect. However, this is one part of it that we realize that how does AI come into play, and is it possible at this moment of time? For us to manage effective and manage students' effective learning in terms of helping them see the point of learning, helping them come to a point where they see that the particular discipline of the lesson actually can be relevant to them. That's one thing that human teachers can do well, but we can do that possibly for smaller classes, whereby we can get to know people. Again, once you go to a higher, larger class level, it is very hard for us to manage that, or at least get a good sense of whether we are actually achieving some of these things. Again, how does AI come into play to actually help deal with that aspect is a question that we have. The other thing that we talked about in terms of it is whether AI can or should come into play at all in the first place is also a question that we're asking, because this then depends on whether it's foundational or complex. And again, this depends on the role of the teachers and the students. Students, one of the things that emerge is if at the foundational level, they use it too quickly, it may shortcut, and we end up actually having learning losses instead of learning gains as envisioned, right? Now, so in terms of this, basically, one of the big questions that we feel that is still, we need to find out a little bit more is, where does AI really help in terms of teaching and learning, what level and what kind, right? To summarize. Last thing is basically all that assumes that our roles as teachers and learners, students in this case, are still relatively similar of what we are currently doing right now. So the other thing that some discussion that came out was that with AI coming in, how does our role actually evolve? Is the role of the teacher still, what is the role of the teacher? One person contributed in terms of that maybe one of the areas that teachers then become is really like learning experiences designers, like learning designers, instead of what we actually understand it to be. Maybe that's one evolving role again. And again, students, what is the role of the student at this moment of time, especially in line with and in light of that generative AI or AI can actually do certain things? How then what is their role vis-a-vis AI to actually learn how to learn well, and what degree they actually need to learn every single skill, considering that this is a tool that they may have access to. So these are some things that we have.
Okay, thank you, Leland. Any quick questions before we move on to the next group? Okay, if not, then group 2 can go. Sorry? Permission to share screen. Okay, so I guess group 2 is going, Kedar will help you, give you permission to share screen. Is it okay? All right, so while we're trying to solve technical challenges here, can I request that the facilitators or presenters who's presenting for each group try to finish in 7 minutes. Then we have 3 minutes to ask questions, and then we can all go home on time lah. Okay, thank you.
Okay, for group 2, I'm so glad we present after group 1, so everything they say is fine. Okay, so we discussed many similar points, but I think we sort of summarized the vision statement.
Essentially, maybe you can do full screen instead.
Full screen,
the bottom, yeah.
Yep. Okay. So basically, we summarize everything in this key vision statement. That is to enhance students' agency and self-directedness for learning and for life, because this will affect their learning, this will affect their well-being, this will affect their employability. Okay, so with that in mind, then what are some of the solutions and challenges? So we sort of put these challenges and solutions side by side for students, for teachers, and then for human AI partnership. So for students, I think one of the things that we discussed is about deep learning. Deep learning, not the AI sense, but deep learning for students. So we're thinking about how do we help our students to learn deeply, understand the content deeply. So scaffolding learning, knowledge building, idea generation improvement. So sorry, knowledge building is quite sneaky. Okay, the group did not discuss about that. But basically, this is actually pedagogical solutions. So in terms of solutions, we have some pedagogical solutions and some AI solutions. Okay, self-directed learning is something that the group discussed quite a lot. How do you use AI, for instance, as a learning companion, and not just learning from AI, but learning companion to help the students to learn? So I think there are 4 examples that the group discussed, but we're not going to elaborate here. Engagement is one issue that we discussed quite a lot. How to engage the students in learning? We discussed about all the measures of engagement, and we realized that some of these measures are actually not quite valid. Okay, so we actually think deeper about how to engage the students better. One idea was to use metaverse. Students go into different rooms to learn different content. In that sense, they have the choice and agencies for learning as well. Communications. One of the challenges we find for our current students is that many of them do not want to communicate in class. They don't ask questions. But if you give them a choice, ask questions through a computer, many questions come in. So this challenges we find in current students. So how to engage them with different modes of communication? For instance, do we want to include assessment through presentation? And this is pedagogical solution. Of course, efficiency of learning, large language model came in again. But one issue that we discussed quite a lot is ethics of learning. So pedagogical solutions, AI detectors we discussed, and then as well, whether that is valid at this point in time, whether it's possible at all, and what are the possible impact on the students. So these are challenges and solutions for students and to teachers. Then teachers, what are the challenges? Assessment. So the current solutions we can use is use unrated data to make learning visible. AI to provide assessment maybe as a way to provide the first draft of assessment that can actually help the teachers to give some comments to students. We need to scaffold the assessment, new modes of assessment, because of current generative AI era. Many students actually use generative AI to do assignment, and plagiarism is something that we discussed earlier, how to tackle the issues. We do not have a clear solution right now. We don't think that current solutions will be tackling this plagiarism. It's fair to students, but what will come next, we do not know yet. Accessibility of teaching materials, we discussed about this, that with the large language models, they now actually translate your materials very quickly, and languages, and that can improve the accessibility of your materials to other countries, other regions, as well as personalized learning materials to different students very quickly. And last, human AI partnership, which Boon also discussed. So we talk about AI literacy for teachers, knowing how to use AI effectively, and knowing how not to rob the students of learning opportunities, and how to design learning environments for students. So this is not what we discussed, but in my earlier discussion, we talked about using AI as a tool versus using AI as a scaffold. So using AI as a tool, you want them to be able to use throughout their life. Using AI as a scaffold, you want to help the students to learn, but they should be able to perform something independently of the use of AI. So this is something that the teachers need to know. AI literacy students, again, we talk about how best they can use AI for learning in an ethical way. So I think this is the summary what the group has discussed. Anything else to say on that?
Thank you, Chee. Anybody else has any questions for the group before we move on? Okay, I want to go home, right? Very good. Three, next. All right. Who's presenting? Okay, good. Go ahead.
I've been arrowed. Should I? Oh, thanks, Ben.
All right. So this was not an agreement. I was only supposed to moderate. But anyway, here I am. So it's great that we're doing after team 1 and team 2 because everything that you mentioned is amazing and great. So we have less to talk about. So our team is discussing on how we can understand learning through the integration of AI and neurobiology. So there's a lot of different ways in which AI can be integrated into classroom settings, but also to understand the molecular basis and the behavioral basis behind learning as well. So we did consider, like, for example, how can these kind of technology be best deployed? But I think one really important thing we need to first recognize is that learning is a very heterogeneous activity. There are many ways it can be conducted. There are many ways it can be facilitated. So we came across with this framework on the different modes and different levels of learning. And earlier you heard Alwyn and others presented about knowledge creation, knowledge building, but we are also interested in the application of learning. So knowledge translation is also important. And earlier, essentially talked about engagement being a very vital mode of learning. And I think underpinning all these different pillars, is the constant need to engage amongst the students themselves, and the need for the students to engage with the teachers and whatever teaching aids they are using. So if we're able to do this effectively, then of course, right, there will be certain behaviors, certain digital and molecular markers, right, that could be used, right, for helping us to understand the neurobiological basis behind this learning. Because, right, the neurobiological features essentially, right, will serve as a surrogate marker. It can predict, for example, your potential to learn, or it can also predict, for example, right, how you can potentially learn more effectively. You know, it can be personalized to some extent. But so we have two extremes here. You have, right, the knowledge frameworks, how to learn, you know, what kind of learning outcomes you have. On the other side, you have the different modalities. You have digital markers, biomarkers, EEGs, right, that was presented earlier, the wearable caps. And then we also have behavior and molecular markers and all that, right? So there's a lot of different modalities that you can get. It is a very complicated landscape. They have different longitudinal and different expressions in themselves. So trying to bridge in between these two, right, I think, right, you know, will be the designing of the appropriate AI technology in order to do this effectively. And this is by no means a trivial task because, right, once, right, we start to think about how do you design the appropriate AI technology, you realize that across, right, the different learning pillars, there will be different modes, right, of achieving these things. So some of these have already been mentioned, you know, collaborative learning, one-to-one, self-directed, and so on and so forth. I think one very interesting aspect, right, that was alluded to earlier is the idea, right, of adaptive learning, right? And we are referring to adaptive learning, not just from the basis, right, of the individual, of the AI itself, but rather, right, the potential, right, for co-adaptation between the human learner and also, right, with the AI as well. So I think Nancy Chen's earlier presentation, right, alludes to some extent of this. But I think if we can take a little bit further, we can think into in terms of how, right, the AI technology can also be construed, right, as a potential team member as well. So in certain domains, like for example in medicine, we do consider whether an AI could potentially partake, right, in the decision-making process as a team member as well. So we think that this concept can also be easily applied in learning, where you can think of the AI as a co-learner with you or as a co-aid, right, to the lecturer as well. So I think these different modes of engagement, right, could present very interesting use cases, right, which we can then use, right, to monitor, you know, what is actually going behind, you know, the scenes of the learner. All right. So coming back to the problem at hand. So what we can see here is that there are many different data modalities, right? If we really want to understand how to use this as a surrogate and how, right, to apply this, right, you know, more precisely to learning. So one of the suggestions that we had in our team, right, was the idea of precision learning or precision or personalized AI. So this is actually, right, a semi-supervised form of learning where you actually can try to figure out, you know, what kind of space constraints, you know, can be used, right, to optimize, right, the predictions to cater, right, to the specific needs of the individual. So I think if we can get if we can exploit, right, the depth of modalities that we can get, right, by understanding what goes on, right, behind the mind, then I think we can do this, right, more dynamically and more precisely as well. So I think with that, I'm just going to end here. So thanks a lot.
Thank you, thank you. Any questions for this group? It's not question group 4, your volunteer, you need a mic? Or do you need the projection? Or is it?
Okay, thank you so much for this good opportunity to come here to listen and discuss these exciting ideas with the rest of you. So we are arrowed by the we will share what we discussed. We know that we are number 4 and probably a lot of good ideas already shared. So what we choose is to summarize and just highlight some key points that we want to share with the rest of you. Okay, so I will start first and then followed by Gongxia. So the questions that we talked about, main thing, the key theme is about critical thinking that we all know that's very important, especially in the era of generative AI. More specifically, what it means that in Singapore, in our classes, we always want our students to ask questions, not simply just accept the facts. But we know that many of them just accept what we give to them, don't question that much. So the natural question would be that we want to teach or get students to ask the right and good questions, not only to us as lecturers, but also more importantly to the AI question, right? When AI provide answers to them, they should question the answers as well. And you know, we know that the AI nowadays feel very hallucinating. From my point of view, actually, it can be good because they make students to think, not just simply just accept whatever given. So I think it's good, okay? So then the other question we are thinking about is collaborative learning. So previously, we would like students to have their study buddy. They can ask each other questions after learning to improve our learning. However, we discussed to say that both are the beginning learners. So it's quite difficult for them to help each other. However, if they can interact with AI behave as a more experienced learner in certain area to interact with the beginner learner students, then it can help students train over time to become more experienced learner. Now, this would be like how to design and how to help students to learn how to use AI in this aspect. Okay, those are the questions that we want to highlight to you.
Okay, thank you. To support the new types of teaching and learning, we need to design different platforms. But on the other hand, we already have a lot of existing platforms. So then how can we add the AI layer? Do we design like a new AI to be embedded in the existing platforms? Or do we design like a new independent platforms, then try to fetch data from our existing like LMS? Then we face some challenges, like we have online data, we also have some offline data. How can we integrate them to understand learning better in a more holistic way? How can we try to cross different platforms in order to leverage AI to better support teaching and learning? And we also know different subjects have their own like characteristics, have their own pedagogies, approaches, and expert domain part. Then we need to involve experts of different domains to design platforms better appropriate for the subjects. So it involves like experts in the design process, may involve them to label data so that the platforms can be better grounded in different domains. But all of this is time consuming and not easy. The next part is AI literacy of the teachers. I think Group 2 already illustrated this very well, so we will talk about this, okay?
Oh, okay, so let me elaborate a bit more on the AI literacy. So just now we were talking about AI for students. Actually, the Prof Shian brought up saying that we should have AI for faculty first, for Prof first. So that's why we talk about AI literacy. It's not about AI itself, more like with the pedagogical integration, that kind of AI idea. Because he shared that they had some app or platform designed by some outsiders, non-educators, and when come to their department, faculty use it, so it's like, oh, what are they talking about? So basically, the idea is that during the development of any tools, better to have some educators involved. That's the idea. Now, we all know that data is very, very important. There is so much data we want to collect, but we think there's one very important umbrella or like principle we should follow would be the knowledge tracing. So we want the AI to track the data that can keep tracking the students' learning progress, so that either AI or educator, we can provide more timely, personalized learning and training for our students. That will be the principle we have in mind. Thank you so much for listening.
Thank you. Any responses or questions? All very quiet, like my students have no questions. Then I want to go home. Okay.
Hi, good afternoon. I'm not an artist, thankfully, not a Bao Bao. So, Bao Bao means I cover the content. So, today our group is very small but very diverse group. We cover SMU, NTU, NUS, and A-Star. So we cover almost everyone. Sorry, SUSS, but anyway, our motivation and goal is actually to look at knowledge creation processes during lifelong learning. So we're thinking about adult learning also, but why do we think about knowledge creation processes? Is because in some ways you're actually acquiring knowledge, you're also acquiring experiences, competencies during your whole life. And why do we actually want to focus on that? It's because if you come across friends or your colleagues or even your spouse, your children, and then when they grow older, then the first thing they ask you is, what can I do in life? And that's a very common question. The second question they'll ask will be, what's career advice? What can you tell me what to do in the future? And there are people who finish a bachelor's and then ask you, what can I do? And you say, do a master's. Okay. After I do a master's, what can I do? Do a PhD. After you do a PhD, a terminal degree, what do? Do more PhDs. So we cannot be having that on and on for the next, I don't know, decade or century. So there are also people who also say, okay, I've done a PhD, then what do? I don't want to be an academic. Then can you go into research, can you go into other stuff? Yes, you can. But in some ways, you still have to acquire and learn about stuff. You have to know more about things. And therefore, there's our challenge whereby we say that adults are not actually lazy learners in a sense. But actually, we do look at it as they are actually rather what we call passive candidates that actually are looking for learning opportunities. However, these learning opportunities are not always prevalent and not always readily available to them wherever they want it to be. And therefore, AI as a very what we call omnipresent kind of tool is able to provide you with that. Because you don't know what to do, you don't need to go to jobstreet.com or look for the jobs and stuff, but you can actually go to a certain site with AI that says, okay, you know how to cook an egg, you know how to cook a hot dog, now you can start learning how to bake a cake, something like that. So that's what AI's affordances actually allow us to do at this point. And therefore, our main goal here is to think whether can AI be used to serve learners as an adaptive system. Of course, the adaptive system itself is very large. What can it adapt to? For AI, in terms of technological affordances and capabilities, almost everything. Why? Because we have thought about a lot of options and a lot of different kind of things that AI can do for you. For example, for adults who have actually progressed beyond studying years, what can you still do? You still can learn about other kind of fields, other kind of technology, other kinds of capabilities. And also, if let's say you're in the arts or maybe in music or portfolio-based kind of jobs, then you can always acquire even more skills in terms of like, can you play more music instruments and all this kind of stuff. So all this fall under what we call adult learning. But in a certain sense, we need what we call recommendation system to be able to help recommend people towards certain things that they want to. There are actually existing implementations of certain stuff like this, but it's actually more for job seeking. That means like you have a job, you don't know what to do, okay, come here. So the job they have is that you say, oh, I want to do cybersecurity. And then the recommendation system says, go be a security guard. But that's AI. You cannot stop that happening, it's AI. So the other concern that we have is that do you actually want to place some right decisions in the hands of AI? And that actually plays into the ethics consideration of things. It's like if I'm not willing to put my kids' results in an automated essay grading system, how can I actually put my life in an AI that tells me, say, go be a security guard? Which in future could actually be with Cisco or something, but then you're doing cybersecurity and not as a physical presence. So the other part that we look at is actually the learner's learning trajectory. The recommendation system and adaptive platform does not naturally need to just be something that tells you once and then you go home and sleep on it, but rather something that actually sustains and goes through with you throughout your life, in which you keep track of your profile, your achievements, your goals. So today I cook an egg, tomorrow I cook a hot dog, next year I bake a cake, and then at the end of my life, I try to be a Michelin chef, something like that. And this thing will be there. It's sustainable, it's prevalent. It's not always something that you just say, I subscribe for $10 per month and I just ignore it for a week. So the last one is actually what we call skills and knowledge transfer. There's one part which I actually missed. The recommendation system is actually about JIT interventions. So we have a colleague who actually does a little bit of airplane maintenance. And then to them, the JIT just-in-time intervention is actually very important. Because in some ways, if you don't maintain things properly, then you might have read the news yesterday, something happened. So skills and knowledge transfer is actually quite critical. So because if there's no handover processor that's readily available to one and all, then what happens is that things will actually, people do retire, things get outdated, and therefore there's no proper handover. And such a system will actually outlive, if not most, but all of us. And therefore, this will also be a archival system where I can keep all those things there for the long term. So that's all I'll share. Thank you. Okay, can you see? Yeah, good. Okay, so hello, my name is Jonathan Sim. I'm a lecturer of philosophy here in NUS. We are actually the wildcard group. You know, we're supposed to fill in the gaps of like what did we not think of and discover, right? So, let me share with you something very exciting that we talked about, right? Which is AI as personalized scaffold for future learning. Now, how did we come up with this? Is because at first we started talking about personalized learning systems. And then we realized, hey, you know what's the problem with personalized learning systems? Students can get the wrong idea that learning is just explicit knowledge, knowledge that can be written or in the form of images. And the more we reinforce that with AI, the more they believe that there is nothing more to learning than words and images, right? So then the question is, what about tacit learning, tacit knowledge, right? Can we do some kind of personalized learning on that, right? But then we realize there's another problem because within our educational systems, you know, we always have intended learning outcomes, learning objectives, right? Now, what's the problem with that? I give you an example. Let's say you start off today as a new salesperson, right? Maybe selling insurance, right? And then your big KPI is what? You need to hit this sales target, right? If I'm an inexperienced salesperson, I will immediately chase that KPI. And I will forget, you know, but an experienced salesperson will tell you, no, that's the wrong thing to do. Don't just chase that immediately. You're supposed to work on other things like expanding your social network and all that, right? But notice how, as a learner, or even as us as educators, the more we put these kinds of learning outcomes, we become very narrow and focused, right? So how then can we use AI to look into tacit learning, to look into things that go beyond immediate learning outcomes? So that's when we started having discussions about where is the gap, right? Right now, we have the individual and we have the environment. A lot of tacit learning is actually facilitated by human beings, usually parents, siblings, and then teachers, right? To connect the individual learner with the environment. But then now, what do we have? So all these sociological issues, parents not around, too busy working, the siblings also not around, or whatever. So now this gap is growing bigger and bigger. So why not, instead of using AI as a personalized tutor for intended learning outcomes, for explicit knowledge, why not we use that as a way to interface, to connect our learners with the environment? That's something that we have always been leaving it to human teachers, to human parents. Why can't AI help and assist in this way, right? So what then are the challenges, right? Of course, the big challenge is it's intangible, right? How can we scaffold, personalize the learning of what we call ability to learn in the future, or learning how to learn? Yeah, or some of us may even call it metacognition or whatever, right? So then the issue is, how, if it's intangible, how do we measure? What are the proxies available to us that we can use to be able to identify that the student has acquired this over the years, right? The other issue is, what is an appropriate scaffold? Now, the AI can personalize it in two ways. One, in the form of direct interaction with the students, in offering the scaffolds to help the student acquire the ability for future learning. The other is the AI to also advise educators. Okay, this is the student's situation and the environment. Here are some recommendations that you as teacher can use, right? But then even within the question of scaffold, there's a lot of debates, because some people say, oh, this scaffold is too much, you're hand-holding, you're mollycoddling. But some people say, no, we need it because, you know, the person is so disempowered. And so we need that scaffold, right? Then there's also the question of when. We may know that this is the right scaffold to use, but when do we execute it? Now, the other issue is this: if you're going to collect a large amount of data, right, we also need to know what is the appropriate context to make sense of the relevant data to make those decisions for scaffolding. Yeah. So that's the challenge. And then what's the community effort? I think what we currently have right now is we have a lot of data. Longitudinal studies of the individuals, longitudinal study of the environment. So as a start, we could take these two and maybe use AI to go through all this data to be able to find connections, so that could be our basis, right? And if we want something very personalized, you know, going forward, we actually have the infrastructure.
right? Like one of our colleagues here shared, actually SingPass could be a way in which we expand the SingPass infrastructure, maybe like just as an idea, because we have all the data protection and governance and everything, to then collect some of this information about our students over time. And then that can help us to gain deeper insights for that kind of personalized learning about learning, yeah? Of course, then there's the question, what's our data queen, right? We recognize we may not have enough information about that, so perhaps we can look at what other regions have this parallel data that we could potentially look at and explore. Yeah, so that is all that we have. Thank you very much.
Right, thank you very much, everyone. For a while, I was worried that people will overshoot the time, but right now it seems that we have some extra time, and I hope you don't mind. So I think Seng and I will try to summarize the session, but I hope you don't mind if I will just shamelessly share with you and add sort of from my team, because a few things. I think this group talked a lot about what cognitive parts of learning, right? Okay, so let me share you some. Okay, I'm a computer scientist, and actually software engineer. My students, a lot of them do software for a living, and some random story. So there's a lot of AI apps, right? So my students are in the midst of action. Okay, so what do you think is the most popular LLM-based app out there? Okay, I know this because my student is one of my students is doing this startup whereby they are actually running a kind of middleware, right, to help companies train LLMs to do certain apps. And anybody has any guesses? I think I told somebody that. So okay, I thought it's usually you can't tell them the title answer. Okay, you will not guess this I suspect. It's virtual girlfriends. Okay, I have no idea because I'm married I would never have any imagination of finding a virtual girlfriend. But apparently, okay, apps are very good at pretending to be human, and then also stories of this like celebrities who are creating this like avatars themselves and making money, right? Okay, so in this light, okay, let me just show you an ad of something that my team has been building. Okay, so it's like a chatbot, but not really. Let me see how I can share. How does it sound? Sorry, is this sound? The sound work? Sorry. Let me share this thing. Okay. Can you see? Okay. This is the. Okay, this. Sorry, give me 2 minutes now. Okay, so yeah, so the fact is that we are building this little AI tutor thing, but the key insight is really that so the young teachers, I mean, I'm not very young, I'm an old teacher, I'm doing it for 20 years, right? So the young teachers will think that teaching is this process of communicating information, right? Transferring knowledge. That's the easy part. Okay, my view about teaching is that teaching is really the business of managing motivation. So in that sense, I think the effective parts are very important.
When you teach a small class, you can cater to the different learning styles of each student. However, the bigger your class grows, the less your personalization can be made for each student. That's where we step in. Introducing Chico, a personalized learning platform built for the next generation of education. Let's see how it works. This is how a typical lesson flows. You introduce some concepts, give some definitions, provide some examples. You check for understanding. If something's not quite right, you clarify. Make sure everyone's clear. And when all is well, you move on. Now, we repeat this for every topic until the end of class. And this is how it looks like at Chico. This is the story where you design and test your entire lesson from start to finish. And your students will see this. Your lesson contents are delivered in blocks of content and action. Contents form the knowledge base. And how they proceed with an action, which is a form of feedback, really, determines where the lesson will go next. And check out that confetti, totally environmentally friendly. Now, students are inquisitive. If at any time students feel like asking something, they can do so right here. You can then answer these questions, send the student right back on their way to mastery. Now, I know what you're thinking. Manually answering every question is not scalable, and we agree. That's why, based on the context and our knowledge, Chico can generate a draft reply that you can review before you send it. And all these interactions are captured in the system, right? So as more and more questions get answered by drafting and human review, our knowledge gets more and more robust. After enough iteration, you can finally turn on auto reply and stream answers directly to the students. But even then, if the conversation is stuck, you can intervene and send them back on track. So you're always in control. You can manage all your students in the mission control and take charge of their learning experiences in one place. Now, this is where we differ from a typical teaching chat, because we don't want the chatbots to take over the learning experience. You already have a great lesson crafted in Chico, so we want to make sure that even if the student digress, they will eventually converge back to the lesson. We call this continuity. Now, let's go over some nifty features we've been developing to make your teaching life easier at Chico. The first is timelines. Schedule is crucial in a lesson. Timelines in the storyboard allows you to pace out different parts of your lesson, so your students are getting the right amounts of learning at any time. And that's time. Next is recall. Teaching is the business of managing motivation, right? Now it gets hard when you aren't even physically there with your students. And the thing is, people forget things over time. And it's described by the forgetting curve. As interactions become increasingly asynchronous, we have to deal with this. Recall is a feature where we tap into the rich platforms that students already use, like Telegram, and deliver reminders, motivators, and contents for them to refresh what they've learned directly to them, wherever they might be. So we're really taking what your students are used to today and build interfaces and interactions around them. And so forgetting curve will look more like this. So you teachers can focus on building the best stories on Chico, and we'll do the hard work to make sure your students stay engaged in them. And that's recall. Next is co-author. You guys teachers already have great materials that you use to teach your classes today. So with co-author, you can just take your PowerPoint slides or those long PDF files, and with some voodoo AI magic, co-author will draft a lesson that you can then test, edit, and publish. We believe that co-author will help you create good stories effortlessly in your already busy schedule. And that's co-author. So auto reply, timelines, recall, and co-author. These features will be coming later this year. Yeah, improving education. So we build a platform that mimics the affective components of teaching and bring them to you so you can direct and design your students' learning experience from newbie to master. Chico is built by teachers for teachers. Here at the AI Center for Educational Technologies, we are seasoned teachers, and we build solutions that empower you teachers to deliver the best teaching experience you can to your students and improve learning beyond singlehood for all.
How was it to buy one today? All right, thank you much. Okay, so before I invite Chee to kind of like summarize and close the workshop, we still have like 10 minutes for any comments and questions of anyone. Right, and that was a shameless plug from my center, but I think it's quite well done video, right? I'm very proud of my guys. Just curious, why is it called Chico? Good question. So, anybody gets it right? I buy you a lunch. Why Chico? Because Chico is teacher in Bahasa. My guys are actually Indonesians. So Chiku, Cikgu, is teacher in Bahasa, in Malay as well as Indonesia. So that's why they came out with Chico. Yeah. Okay. All right. Anybody has any questions before we? I think it's really interesting, and the whole bunch of things like effective learning, lifelong learning, adaptive learning. You know, and I think David actually said this very important thing that I thought was really interesting, which is that we focus a lot on measuring outcomes, learning outcomes. That's normal, right? But the real question is really, as AI takes over, more or less, the knowledge is less and less important, but really the focus on learning how to learn and figuring out whether students actually have learned the skill of learning is really important. The question is whether we can measure that. Okay. So anybody has any questions? Sing.
So I just want to summarize it by saying that after this, what happened is so we're supposed to draft what we learn. Basically, we're helping NRF to scope a call. Okay, so your participation is very important because that will help to NRF to come with the call, and therefore you can eventually contribute to that. Okay, so I think that's very important, and so we might be going back to you to get some more information. And personally, I think I learned a lot from this session. I know a lot more people who are very talented, doing very good work. And I learned a lot more new ideas. So I'm not quite sure about you, but I personally I gained a lot from this session. If anything, please know each other, get email and start collaborating one another. Thank you very much.
Thank you. Okay, before we really call it a day, we have 10 minutes left. I mean, I can release it early, but I don't. If you have last call, don't be too shy. Anybody has any thoughts or questions? Okay, and to paraphrase what Seng says, basically, NRF is going to give out money, yeah, right? So this is your chance to try to steer NRF towards give money in the way that you that makes sense for you, lah. Right? So hopefully you'll participate and help us out. We are just doing like national service to try to frame this thing. Very last minute thing we just have to do lah because kind of obliged to do. Right? Anybody has any last questions? Oh, also quite a question. Okay, never mind. So before Seng closes, I'd like to do one last thing, which is very important, which is thank Hans and Fadila. Okay. The two was quite lovely. Thank you very much. Apparently Hans is a really experienced caterer. He's done many of these sessions. It's also really quite a last minute rush to get everything together and of logistics. So I think I thank them. I'd like to thank actually I've got to thank them, the people who are joining us on Zoom. Okay, I'm so sorry we couldn't figure out a way to do the interactive thing with the Zoom thing, but hopefully this session has been helpful for the people joining us today on Zoom. And obviously, I'd like to thank the facilitators. Okay, sorry, after this is the dismiss you're not, you all need to summarize for us the table discussion so that two of us will not die next week trying to come up with the No, you're not dying. Okay, so thank you much. So let me just thank the facilitators. Many of you have been arrowed to do the presentation. Thank you much for the very good presentations. And then I'd like to thank all of you, obviously, for turning up today, because without you, no workshop, correct? Okay, thank you much. Okay.